Good afternoon, all my dear students.
Good afternoon, sir.
Okay, thank you. Okay, still more students are joining. Just 1 or 2 minutes. I will start.
Okay, sir.
Only 77 students are present. So please, all my dear students, give good strength. Regular, you have to attend the classes without missing any single class. Out of 139, only 80 students are joined. What about remaining?
Sir, 1 minute ago, only 1 minute ago, DMS lecture is end.
Any other lecturing is going on?
Now end,
Okay.
sir.
Okay. So because today I got only 1 hour, no, as per timetable. So if how much early you are joined, that much is benefit for us to complete the syllabus, to coverage of your all doubts, questions. Okay. Yes, fine. Anyhow, parallelly we have to give admitted to everyone, and I have to start uh, my class. So up to they have to join. I will discuss some previous questions asked by you and your friends in your classmates. Okay, so for that, as the last time, how I have to made this you that is so again these are the questions asked by the students. So that is open forum discussion questions from students by today. Okay, so one question I got as in our group, one of the student is asking, so what is the term offset address? That time also I will answer, and now also I will give an answer to them. The first question is, what is the term offset address? And second, one more question I got from another student, that is explain the pipeline processor and non-pipeline processor. Okay, for that also I have to give an answer immediately on that day. But today also I have to explain that. And the third question from another student, so what are the advantages of 8086 over than 8085? Again, I will answer and I'll explain now. And next, one more question I got, sir, I am read this term. So he sent that clearly screenshot, that is in this he may got doubts. So what is that his doubt is, I am read this term 3 times, I can't understood exact meaning, please explain. Sure, I will explain. So I will explain these things, but I'll give clear. First I will cover all the questions, whatever questions I come. So next one, question number fifth, that is the question number fifth. Here sir, yeah, very interesting. This one is very interesting. I am really appreciate with this student. सर थोड़ा सा एक्सप्लेनेशन हिंदी में भी करेंगे तो बहुत समझ में आएगा. ठीक है. I will try to cover this. I will try to use Hindi languages. हम पहली बार सीख रहे हैं ना, इसलिए मीनिंग समझ में नहीं आता. तो हिंदी में बताओगे तो याद में आएगा एग्जैक्ट मीनिंग. ओके, सो जिस जिस को मराठी नहीं जिस जिस सर को मराठी नहीं आती थी वो हिंदी में बताते हैं. So okay, so for this my answer is okay. I will ready to explain you in Hindi also. Whoever comes from the rural background, villages people, and if you are not perfect in the English, you may get difficulties for understanding English. थोड़ा थोड़ा मैं आपको हिंदी भी यूज करेंगे और वो मेरा एक्सप्लेनेशन के टाइम पे हिंदी में भी बताएंगे, उसका कोई दिक्कत नहीं है मुझे। आप हिंदी में परफेक्ट हो, आप हिंदी में समझने दे तो आई विल यूज द हिंदी, नो प्रॉब्लम। ओके, so for that my answer is okay. Thank you for your thank you. Now onwards, I will use your interested language except Marathi because I am not fit with the Marathi. So out of Marathi, आप हिंदी में चाहिए तो हिंदी में बताएंगे, इंग्लिश में चाहिए तो इंग्लिश में बताएंगे। These two languages are commonly we use, है ना? वो दोनों language use करके I will explain you, no doubt. Okay. So next question. Uh, I heard microprocessor also used in traffic signal light. Yes, one of the students is asking this question, sixth one. I heard microprocessor is used in traffic signal light, microprocessor to do programming. So you don't think too much about that because now we are going to theory part. अभी हम theory part पढ़ रहे हैं. First unit and second unit में क्या है? Only theory unit पढ़ रहे हैं. हम whenever we go to the real programming concept, अभी थर्ड यूनिट के बाद बिलोंगिंग टू थर्ड यूनिट हम वो प्रोग्रामिंग कॉन्सेप्ट पढ़ रहे हैं। उस टाइम पे लैब का प्रोग्राम भी करने वाले हैं। दैट टाइम आई हैव टू एक्सप्लेन इट यू अबाउट दिस प्रोग्रामिंग लाइट टॉपिक, सिग्नल लाइट टॉपिक कंट्रोल प्रोग्रामिंग, आई विल एक्सप्लेन यू। ओके, अगर मैं अभी एक्सप्लेन किया तो अभी मैं लैब का प्रोग्राम स्टार्ट ही नहीं किया था, आपको कोई भी इंस्ट्रक्शन पता ही नहीं, because today I have to start addressing modes. From that you are getting real concept of coding in the microprocessor. So that's what once we start lab programs, that time I will give you complete solution and answer and output for this question. Okay, the question number 6 who are asked, please you remember in the lab once we started, that time I have to give you complete solution and I will give you complete code for the program, and we have to execute on the TASM software and we will get the output. Just you have to wait for this question up to we have to start the lab programs. Is it fine? So for that, what is my answer? This program I will explain you while doing the lab programs. Okay, अभी हम lab programs करने के टाइम पे ये प्रोग्राम हम एक्सप्लेनेशन करेंगे। उस टाइम पे आप समझ में आएगी, बिकॉज still I didn't started any coding of microprocessor. So just you have to keep pending, and whenever this time comes, I will explain you in that time. Okay. So next one question.
Hello, sir.
Yeah.
Sir, some student in waiting room.
I admitted to everyone. I given. They may admit it. Only okay. One of students are waiting. Okay. I given parallel. I given admit to everyone. No problem. Yes, fine. So next question, seventh question. One student again asking, what is ISR? So here only it becomes ISR. So ISR in the sense that is uh, interrupt service routing. Interrupt service routing, again as I said earlier, interrupt topic we have to study it in 6th and 7th unit. That time all different types of interrupts I have to explain. Just wait for up to 6th unit of this subject. Okay, in that time I have to explain internet service protocol. So in a single line now I will give you the answer that internet servicing protocol ISR, what it will give in the internet while you have to use the mic अभी microprocessor आप use करते हैं ना program पे, so that time to give a particular path to service, that is to the routing. So routers are there, so for the routers it will give a particular pin to path for the execution of the instructions. That one we have to say ISR. Just only you have to remember for this. Please mute it.
Hello, sir. Sir, you are not audible.
Is it not audible?
Yes, sir, now audible.
Okay, fine. This is the interrupt service routine. That interrupt service routine we have to use it for to service the protocols from sending one to another, from microprocessor to kit to microprocessor. That time this interrupt service routine we have to use it. That interrupt service routine we are going to be studied in the unit number 6. So that is entire topic is interrupts only. So up to that, please you have to wait. Okay. So next one, that is the question. One more questions I have to got, that is what is the difference between microprocessor and microcontroller. So microprocessor and microcontroller differences, lot of differences are there, but microprocessor is too much 8086 too much, that's more advantages. Okay, so this is the one list out I have to made for microprocessor and microcontroller. So this one I will explain you now. So now these 8 questions I got from the students within these 3 to 4 days. So now I will explain one by one. So now first you have to come to the point, that is one question from your student. First question, what is the term offset address? Now I will explain you, all of you please carefully listen. As I already explained in the unit number 2, मैंने already unit number 2 में explain किया था, वो 8086 is the 16 bits का है. 8086 the capacity is 16 bit का है, but the address bus, whatever you studied, the 3 different address bus, that is control bus, data bus. So the address bus का capacity क्या है, 20 bit का है. So address bus का 20 bits की capacity, that length is 20 bit, but actual our 8086 is 16 bits. So remaining 4 bits we have to adjust to a spatial register. What are those spatial registers? These are the some segment special registers, CS, SS, DS, and ES. So CS is nothing but what? Port segment, stack segment, data segment, and extra segment. So by using these 4 extra bits used in this 20 bits, so wherever we have to use these 4 extra, that one we have to say upset. All these entire clarifications I have to given register used to compose the 20-bit address to fulfill of that 4 segment registers, that is data code segments, stack segment, data segment, and extra segments. These are used for the, for that we have to say it is a offset register. So in that, that is a 16-bit register in the 8086, and that starts with 16 bit. Remaining left is 4 bits, right? So that 4 bits are filled by the offset registers. 4 registers are the filled by the offset registers. So those are, it may be a AX, BX, CX, DX, ABCD registers, or there is some special registers, that is a base pointer, stack pointer, internet a protocol, that is source index and destination index. So these are filled with that remaining length of the address, that is out of 20-bit addresses, 16 bits are filled by with the 8086, and remaining 4 are remaining. Those 4 remaining bits are filled by these special kind of things. That one we have to say address, that is offset address. In that there are 2 types, segment address and offset address, but you are asking only the offset address. So segment address are nothing but these are the segment addresses we have to use it in the one aspect, and in the another aspect we have to use it these register, general purpose registers we have to use it. This one we have to say offset address, remaining in the 4 bits out of 20-bit line in the address bus, remaining except 16 bit of 8086 we have to use remaining 4 bits. That's one we have to call it as offset address. So this way, advantage of using this offset address is that we need to give 20-bit complete address. What is advantage? To fill that entire 20-bit, we have to use this offset address. By just providing the offset, we can easily work on this microprocessor. Okay. So this is the answer for your first question, that is offset address, why we have to use it in the microprocessor. Okay, am I clear? I think. Please give me a message who asked this question. if you are clear, and I am thankful to you. Because of you, everyone got understand about the upset address. Thank you so much for who are asking first question. If you are not clear, please separate message me, no problem. Okay. So next, I will move upon second question. What is the second question? Sir, explain the pipeline processor and non-pipeline processor. So here, please allow me. Yeah. Again, someone are waiting. Yes, I admit it. Fine. So see, listen here, pipeline and non-pipeline. So pipeline means in the data structure also you have studying stack and queues. Okay, what is stack? What is queues? In the stack, whatever you are given to adding first in, last out, or last in, first out. But in the queue in the sense what it is kind of pipelining, right? Pipelining means what? Continuously. But in the queue it is opposite of stack in the sense that is first in, last out, but in the queue that is first in, first out. So this queue you have to compare with the pipeline processor, and stack you have to compare with the non-pipeline processor. So in the pipeline processor, the instructions get executed. Okay, first question, sir, clearly understood. Yes, thank you. I got your apology. Yes, fine. So now I'll move to second. In that pipeline processor, so the instructions are continuously execute one on another, whatever sequentially you have to arrange it. That one we have to say pipeline processor. And in the non-pipeline processor, it is a randomly. The instructions are taken randomly and executed as per the priority based. As per the priority based, it is going to be executed. That one is nothing but non-pipeline processor. So here 4 points I have to mention, especially this pipeline and non-pipeline वो कहाँ पे आता है? वो ये जो 86 आर्किटेक्चर में आता है. So in the 8086 architecture में we have to study two main parts, right? One is पहला we have to study bus interface in it, and second one we have to study execution interface, right? That is execution unit, bus interface unit and execution unit. So bus interface unit में आता है a pipeline processor. So in this, the processor fetching the next instruction when the present instruction is being executed. When the present instruction is being executed, it is going to be fetched to next instruction. That is the pipelining. Please clearly understand, the pipelining is nothing but it is the process fetching the next instruction whenever the one instruction already going to be execution under the execution is being executed is called a pipelining, is called a pipelining. But in the non-pipelining, one instruction completed, then only it is goes to next instruction. One instruction execution is completed totally, next it is goes in the non-pipeline. But in the pipeline, parallel it is going to be executes one another. Okay, that is the first point. And in the second point, the pipelining has become possible due to the use of 6-byte queues. It's only possible because of 6-byte queues. That is only happening in the 8086 microprocessor. So because it is a more capacity, 6-byte, 6 into 8, how much? That is 48 bits. Okay, 1 byte is equal to 8 bit. But so that is a it is 16 bit, right? Totally it is 16 bit. But in the 8085, that's the 8 bit. It is not possible. Pipelining is not possible. That's what 8085 we have to call it as non-pipeline processor. Okay, and in the third point, bus interface unit comes under 8085 architecture. It fills that in the queue until the entire queue is filled. Until the entire queue is filled in the bus interface unit, that time we have to use it. In the last one, the bus interface unit restarts filling in the queue when at least 2 locations of the queue are vacant. Why it is 2, at least 2? Because it is a twice of 8085 non-pipeline processor. So for this we have to use it. pipeline and non-pipeline of these two processors. So I think, am I clear? Who are asking this question? You also very much thankful to you. Because of you, today everyone is got this concept. Okay? Thank you so much. Please message me if you are cleared. If you are not cleared, also please message me one more time. I have to explain, no doubt. So next, I will move to the question number third. That is, what are the advantages of 8086 over 8085? So 8086 having a more advantages. 5 means it's a 16-bit, supporting 16-bit, and it is supporting a pipelining. So all points I have to explain. So first, the drawbacks of 8085 I have to explain. 8085 is a 8-bit, but 8086 it is a 16-bit, and 8085 has a 8-bit data bus, but here in the 8086 16-bit data bus, and it has a 16-bit address bus. In the 8085 the 16-bit address bus, but here in the 8086 20-bit address bus, remaining 4 bits are filled by offset address, as now only I have to explain. Okay, so next one, अभी वो चौथा पॉइंट क्या होता है, that is only 64 kilobytes of memory can be used. अभी हम 8086 में only 64 kilobytes of memory हम यूज कर सकता है, लेकिन इन 8086 हम 1 MB तक मेमोरी यूज कर सकता है. Okay, that's the capacity of 1 MB in 8086, but here only 64 KB of capacity in 8085. That is the one more advantage over than 8085. And next one in 8085 is having only 5 flags, as we studied in first unit: carry flag, parity flag, sign flag, zero, auxiliary carry flag, and zero flag, right? So only 5 flags are there, but as we studied in the 8086, 9 flags are there. That's the more advantages. That is, those are अभी और 9 flags कौन कौन है? That is carry flag है, parity flag है, sign flag है, zero flag है, auxiliary carry flag है, direction, trap, interrupt, and overflow flags. All 9 flags we have to study it in 8086. That is the one more advantages. And abhi wo next advantage is it has minimum mode and maximum mode. So in the 8085 is a minimum and maximum mode hai, but here in this operated that 8086 is operated any one of the mode, either minimum mode or maximum mode. But 8085 it operates in both the mode. That is the one advantages. So that is the one advantages of 8086. It is operated any one of the mode, either in minimum mode and maximum mode. So this question is asked by one more student. I'll explain you, no doubt. Okay. So next one, 8085 is, as I explained now, it is not supporting pipelining, but 8086 is supporting pipelining. So and one more, the 8085 instruction that computes the multiplication and division operation, but here in the 8086 it supports integer also, all types of integers, decimal points, and ASCII arithmetic operations. All types of ASCII arithmetic operations also possible, but it is not possible in our 8085. So next difference is, next advantages is it operates only in 3 frequency. 8085 और क्या है, only 3 megahertz frequency में operate होता है, लेकिन here in 8086 ये इसमें 8086 operated in 5 to 10 megahertz, more than 3 times. 5 to 10 megahertz it is working. So last point, अभी क्या advantages है, it operate the memory space are very less and not segmented. We don't use any segmentation in the 8086, but for the our usage, frequently usage, reusage, we have to use memory space are segmented. They are segmented means what? Different parts of memory, we have to make it abroad the single memory. That is possible. So this is the benefits over the 8086. Okay, so I think I cleared this question. Third question, who are asking, please you ping a message if you are cleared. So thank you for you. Because of you, everyone should got I really am very sorry for you student. you read it out 3 times, even though you may not understand up to the mark. Really, because I'll tell you what is the point. Because this concept I didn't explain to you. So minimum mode and maximum mode, these two are comes under fourth unit. Actually, I need 1 hour to explain these two. So I will show you in that your syllabus. So see, all of you just visual the syllabus. That's the unit number 4. In the unit number 4, there is a concept of minimum mode and maximum mode. So it needs minimum 1 or 2 hours to explain this topic. So so that's what you I didn't started this minimum and maximum mode till now. Just I use one point. What is the advantages of 8086? In that, just I mentioned this point. And dear student, I am very sorry because I have to explain this question, minimum and maximum mode. Please you keep pending because I need 1 or 2 hours to explain this entire concept in the unit number 4. अभी चौथा यूनिट में हम पूरा इसके ऊपर एक्सप्लेनेशन करेंगे. So just you have to understood that minimum mode and maximum mode means, minimum mode means क्या होता है, ये थोड़ा फ्रीक्वेंसी में ही ये ऑपरेशन हो जाएगा, और मैक्सिमम मोड क्या होता है, इसका फ्रीक्वेंसी थोड़ा ज्यादा हो जाएगा. So all these things I will explain you in the unit number 4. Please all of you keep pending up to we are go to unit number 4 because it takes more time. Once I explained you in the 4th unit as per your syllabus, that time you will clearly understood. Okay, so just I will keep pending this question, dear student. I will explain you in that time. So ISR also I have to explain it, no problem now only. And this is the question. So this question, one student, now I am using Hindi, no problem. At the question number 5, सर थोड़ा सा एक्सप्लेन हिंदी में भी करेंगे तो बहुत समझ में आ जाएगी. ओके ठीक है, आई विल स्टार्ट टू एक्सप्लेन. अभी अभी थोड़ा हम हिंदी में यूज करता हूँ. हिंदी आई एम परफेक्ट, नो प्रॉब्लम. आप लोग हिंदी में भी क्वेश्चन पूछ सकते हैं, हिंदी में भी मुझे साथ बात कर सकते हैं, हिंदी में भी कॉल करके आपका कोई तो प्रॉब्लम है तो भी मेरे साथ क्लियरली आप डिस्कस कर दीजिए. ठीक है. Okay, is there any more is in the waiting? Okay, no problem. Yes, fine. So next question, and that is I heard microprocessor question number 6. I have and please who are say ask this question, fifth question, please everyone say thanks to him because it is applicable to everyone, right? Okay. So now I'll go to the question number 6. That is topic signal light programming. So dear student, please you don't hurry up. I didn't started any of your microprocessor program. So I'm really appreciate your interest to learn on this. But whenever we have to started, once we studied all the instructions, after that we will go to this program that is topic light control program, topic signal light. So that time I will explain you. Don't worry, just you also keep for this question up to we are starting lab programs. Okay. So if I explain, it means you didn't understand because that program is go through that all the instructions, programming code. So for that, I will just wait for this question. I will explain you in the lab programs. Okay. So for that, this program I will explain you while doing the lab programs. Okay. So I think this 6th one also keep pending because still we didn't reach to that level. Okay. So next one, what is ISR is nothing but an interrupt service routine. So this one also we will study it in the unit number 6. That interrupts, different types of interrupts are coming. That term we are going to study. So next one, what are the difference between microprocessor and microcontroller? So these are nothing but, so I have to made you one list. So this entire questions again I will dump it in the microprocessor group. All of you go through it. So what are the difference of microprocessor and microcontroller? The microprocessor is like a heart of the computer system, but the microcontroller is like a heart of embedded system. It's a computer system related to computer, that is microprocessor, and microcontroller that is related to embedded system. So it is in the microprocessor, it is just a processor, memory and input output components have to be connected externally And in the microcontroller, it is all our external processes along with the internal memory and internal input output components are used in the microcontroller. So next one difference is, since the memory and input output has to be connected externally, the circuit becomes a large. So in this microprocessor, the size of the circuit is too much large, and here it is a optimum. That is optimum in the microcontroller. So in the microprocessor, it cannot be used for the compact system because of large size, and hence it is insufficient. But it is a possible in microcontroller, that is can be used for impact system, and hence it is an efficient technique. Okay. So like this, cost of the microprocessor is more, and that cost is less. And due to the external components of entire power consumption in high, hence it takes a lot of power suitable to use it with the devices running to shorted power like batteries. Okay, but this problem is not there in your microcontroller. So, and the next one is, for the microprocessor, you do not have power saving features, but that power saving features are there in the microcontroller. Since the memory and the IO components are external, each instruction will need external operations, but it is solved by the internally. That's the internal instructions, and hence the speed is too much fast over than microprocessor. So, and next point, that the microprocessor has less number of registers, but here in the microcontroller have a less more number of registers to store the large number of capacity. So, and one more, that is the microprocessor are based on Van Neumann model. So this one will be good. Just I have to added one point. So the last point, that is in the microprocessor mainly used for personal computers, and this microcontrollers mainly used in washing machines, MP3 players, like that. So these are the many out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 differences I made a list. Please all of you go through it. So what I will do now, so I am very much thankful to last question, difference between microprocessor and microcontroller. Thank you so much. Because of you today, everyone is got understand this concept. So please, all of you, whoever asked this question, if you are sufficient with my explanation, please reply me. If you are not satisfaction, also please reply me. And out of who are asking, other students also, if you are not clear, please again you ask the questions. If you are clear, I am happy. Okay. So now what I will do, I will transfer this file, this today's discussion forum into your microprocessor group, that is in the microprocessor group. So yes, what we take? Okay, okay, sir. Yes, fine. Here I have to dump it into this. Desktop. Where is that? Okay, 20 date. This is today's. So yes, fine. Open. Yes, now I dump it into your microprocessor common group of my subject. Please, all of you go through it. So अभी वो क्या कर दीजिए सभी लोग, वो जाके पढ़ाई कर लो, और you also try to ask the questions like your friends. Okay. So yes, fine. Yeah, if you are got clear, complete from you. Okay. Yes, thank you. That is 29922. Thank you. No problem. Okay. Yes, fine. Is there? Sir, I clearly understood. Fine. Please allow me. Please allow me. I think I allowed to everyone.
Yes, sir. Yes.
Yes, fine. Yes. Okay. Mm. Yes, I think I cleared. Okay. Fine. So this much, whatever I got the questions, all questions I covered. So again, same procedure will be carry on. Whatever the questions is there, आप सभी लोग ऐसा ही आप क्वेश्चन मुझे करते रहो, मैसेज करते हो, whatever doubts in your mind, and whatever you are asking, my all the questions I have to explain to you in the lecturing, no problem. Like this we have to understand each and every concept of the microprocessor. अभी आसान है, बहुत इजीएस्ट है, आप कोई भी उतना उतना घबराना मत. ओके, यू डोंट हैव एनी फियर विथ यू, बिकॉज ये सब्जेक्ट तो बहुत आसान है, तो क्यों, व्हाई शुड वी हैव टू कीप फियर? सो आई विल मेक यू इजी इन ऑल द कॉन्सेप्ट, नो प्रॉब्लम. सो नाउ आई विल मूव टू द टॉपिक, to the second unit. So with my notes I have to start. See, here in this I have to cover the 8086 architecture today. Now I will move to internal operations and machine languages. Today I have to cover these two topics, internal operation as well as machine language instructions. Today I am going to it. Now I will go to internal operations. So come to, okay, one student is waiting, it's fine. So now come to the topic, that is my notes. All of you have with my notes. That's fine. So okay. So now I'll start actual class, that is internal operations and addressing modes, machine languages. Okay, last class I have to cover all 9 flags. Now we will move to internal operations as per your syllabus, second topic of second unit. अभी हम internal operation topic start करेंगे. So all my dear students, in the internal operations, there are mainly 3 instructions we have to use it. Those are nothing but first instruction, second instruction, and third instructions. One by one we will study. So in that internal operations means what? How the microprocessor, once we know the architecture of 8086, internal whatever the program counter. So अभी हम क्या करेंगे, program counter से we have to send the next instruction in the internal operations. And one more thing, what we will do, we will putting it in the register, whatever the storage memory is there, that's the register, and decoding it file. So registers and decoding you studied in the 8086 architecture. So use this registers and decoding, and while the program counter is implemented to point next instructions in the internal operations. And अभी हम third point में execution करने के time पे executing any instructions, and it if the branch is to be taken, अभी हम branch के तरफ से दूसरा रास्ते से तरफ से हम instructions को वो execute कराएंगे. So that is also possible in the internal operations, and that is resetting the program counter to the branch address. And one more thing, last one, that is you have to repeating all these 3 steps from 1 to 3. That cycle C is going to be completed until and unless you have to get the complete output. So these 4 steps are very important for the internal operations. And in that internal operations, we have to use internet protocol code segments in the 16-bit data bits, and first in first out as your queue. We have to use it So for that, in the 8086 address, we word which begins with the with either add odd address or an even address. अभी हम odd address से भी start कर सकता है, अगर even address भी start कर सकता है. Wherever you have to use the started memory with the address of odd or even, that one we have to use it in the internal operations. And along with that, for odd addresses, two memory references we have to need, that is required of two memory references, one memory access for the low order and one more memory is access for the high order, because H and L, the two parts are there along with the register. Either L means low order or H means high order. That one also we have to use it in operations, internal operations. So that time we have to save the words are stored at only even numbers or even addresses, even though 8086 instructions may be from 1 to 6 bytes long. 6-byte queue makes it possible to bring the instructions in a word at a time using even addresses. So always we have to started with many things. We have to started with even addresses. So कभी कभी हम वो मेमोरी के अंदर ऑपरेशन, मेमोरी इंटरनल ऑपरेशन के टाइम पे हम क्या करना है, हम ये इवन नंबर, मे बी इट इज 1000, maybe it is 2000, 3000, that is starting memory address, we have to start with the even numbers. Okay, so the problems occurs whenever there is a branch to add address, but this is resolved as the 8086 brings in the 1 byte and then continuous with even address words. So that's what we have to use with the 1 byte of even address as continuously. So next, these are the three main instructions: 1 byte instruction, 2 byte instruction, 3 byte instruction. That one clearly I will explain you in the diagram. In that, so first instruction, that first fetch, we say this one is a first fetch. That is a first instruction. It takes only one instruction. One block is there here. So I made it as only one block. In the second one, there is a second fetch. And later on in the third instruction, three blocks are there. 1, 2, 3. Entire this proportion. 3 blocks, that is the third fetch. Like this, that even numbers are going to be how to fetch and do the internal operations based on the memory started point, that is even numbers. Okay, so this one, that is the first instruction, has an even address. Same way you go for odd address. First instruction has an odd address. What you will do? Please, any question? I admitted to everyone. Is there any question? Okay. So in the even address, or in the odd address, so first instruction only 1 byte. This is also first fetch is only 1. And in the second instructions here, it is a 2. Second fetch is 2. And in the third instruction also here it is 3 blocks. That is last one is fourth fetch will not be begin until the word is available in the queue. So because ours is only up to third instructions, that's what we have to use it. So in the microprocessor, you have to use a number of instructions, but up to now still we have to study maximum 3 instructions. 1 operand, 2 operand, maximum 3 operands. That's what we have to mention up to third instructions. First instruction, second, third. Same. Odd and even by looking diagrams are same, but here it is changes. Here it is everywhere it is 2 2. Here one instruction, 1 block, second instruction 2 blocks, third instruction 3 blocks. But here the fetch is every time it is 2 blocks only. But here this is changes in the odd instructions. Here first one is only 1, second is 2, third is 2, and one more. That remaining one is going to be for the fourth fetch. It is wait until the queue is available. Okay. So this is all about internal operations of the 8086 memory. So now I will move upon some machine language instructions. See, as per your syllabus, just a second. Okay, so as per your syllabus, S5. So whatever now I have to explain, that is the internal operations. So next I will move to machine language instructions. So this machine language instruction is very important. ये बहुत महत्वपूर्ण है आपको. ये सेकेंड लेसन पे मशीन लैंग्वेज इंस्ट्रक्शंस. अभी आप लोग ये मशीन लैंग्वेज इंस्ट्रक्शन के ऊपर अगर परफेक्ट हो गया, means it is very much useful for your lab programs. So all instructions are comes under this one only. Many of the instructions are comes under this one only. So all of you please be concentrate on machine language instructions. Now I have to move with machine language instruction. So that is in the machine language instructions we have to use it opcode and operands. Opcode we have to say that is the operational code. In the instruction is divided into two groups, that is opcode, that indicates operations code. Whatever operations is going to do with the particular instruction, that one you have to say opcode. And operands, operands are nothing but what, whatever the operation is done with the parameters, those are nothing but operands. These are the indicating information needed to carry out the task. Once that operands may contain data, address of the data, or indirect pointer of the data. So by using these points, we have to use the operands. So the general instruction format is general. So every times you have to heard about instruction, right? So actually the instruction general format, this is the general format of instruction. What is that? Opcode and operand 1, operand 2, operand 3, up to the operand n. Okay, so one part is opcode, as I explained here, indicates that this is the operational code. Actually, this is the instructions, and these operands are nothing but that is operands. In the mathematics also you have to heard that operands, right? What are the operands? These are the parameters which is operated by some other operations. So here in the operands you may use all the kind of registers. So n number of operands you have to use, but along with that only one opcode, one instruction you have to use with the n number of operands. So in that there are two types of addressing mode. One is general addressing mode and one more is branch addressing mode. So in that I am going to explain first general purpose addressing modes. So there are mainly 5 types of general purpose addressing modes are there. Mainly 5 types of general addressing modes are there. I have to listed, that is data related addressing modes and branch related addressing modes, mainly 2 types. So among of that, in the data related addressing modes, again there are 5 types. First one is immediate addressing modes, second one is register addressing modes, third one is direct addressing modes, fourth one indirect addressing modes, and again in the indirect addressing modes, register indirect addressing and register direct addressing modes are there. Register relative addressing modes and the base index addressing modes are there. So base index relative addressing modes are there. And last, that is the fifth one, is implied addressing modes. So now after that we will move through that. So each examples also I have to given for each and every register addressing modes. After that we will go to branch related addressing modes. Now we will start with data addressing modes, data related addressing modes. Okay. So in that data addressing modes, there are 5 types. Data related addressing modes, there are 5 types. First one, that is immediate addressing modes. So in the immediate addressing modes, what it will do? It will operate suddenly, immediately. That's what we have to say, immediate addressing modes. In this, the operand or the data is specified in the instruction itself. Only one instructions we have to use it. The data specified in the instruction itself is nothing but the immediate addressing modes. Okay. So here, and it provided data may be 8-bit or 16-bit. 8-bit for 8085 and 16-bit for 8086 in this addressing modes. For example, here I have to use one instruction is nothing but a data. Data is nothing but what, a instruction. Example. So this is the one instruction move. The move is nothing but what? Movable. The meaning of move instruction is move some data from. So move some data from. So here CL comma 12H. So this is the instruction. Move CL comma 12H. In the sense, move means you have to move. You have to transfer one place to the another place. That is a move meaning. And CL is what? So in the architecture, you have to study 4 to 5, 6 registers. A register, B register, C, D, E, H, like, right? So here C means the register. CL in the sense what? It is a low bit. It's a low bit register. And what is that 12H? H in the sense it is a hexadecimal number. H is nothing but it is hexadecimal number. So 12 hexadecimal number. The meaning of move CL comma 12H is nothing but 12 hexadecimal number you transferred it into C register of the low bit. C register of the low bit. That is the meaning. So 12H you transferred it into CL register. 12H you transferred it into CL register. That is the meaning. And next one, second example, move CX 1, 2, 3, 4. So CX in the sense what? So this C is nothing but a C register, and X is nothing but what? That X is either it may be a low or it may be a high. If anyone we can use, that time we have to generally use it X. So X is nothing but either we have to use a low bit or we have to use a high bit. So that's what you have to use it for the high 1, 2, 3, 4. That 1, 2, 3, 4 value is going to be transferred it into C register. That is the meaning. Okay. So this is the immediate addressing modes. Very important this concept. Please all of you carefully listen. So इसमें हम क्या करना है? अगर हम ये 12 वैल्यू ट्रांसफर टू ए सी रजिस्टर, so this is the instructions we have to use. So इधर भी 1 2 3 4 5 वैल्यू, अभी हम सी रजिस्टर को ट्रांसफर करना है. अभी it may be a low register or high register, that time we have to use this instruction. Okay. So in next one, that is register addressing modes. In that register addressing modes, we have to use these kind of registers. Either AH or AL in the sense AX, BH or BL in the sense BX, and CH or CL in the sense CX, and DH or DL in the sense DX register. We have to use it in the register addressing mode. Because these are registers we have to use it. So for that AHL we have to say AX, BHBL we have to say BX, CHCL we have to say CX, and DHDL we have to say DX. Along with that, source index, destination index, stack pointer, and base pointer with the 16-bit registers. So how? So here you have to use only one instruction, one data, but here you have to use the instruction with the register and register with the data, because it is a register addressing modes. So in that again move CL comma DL, what it will use. So in previously what is there, here you have to use the value immediate, just one value transferred. But in the register addressing modes, what you will do, whatever the value is containing the DL, D register is containing a low bit value, that one you transferred it into low bit value of C register. समझ में आएगा? सो अभी डी रजिस्टर वैल्यू में वो क्या डेटा है, क्या इंफॉर्मेशन है, वो डेटा सी को ट्रांसफर करना है बाय यूजिंग डायरेक्ट रजिस्टर एड्रेसिंग मोड्स. So in previous what you are using, here you have to use the register, but here you use the directly value, but here you transfer instruction register to register of data. So this DL containing a data with the register D, and that instruction is moving with the C, that's the register C. So whatever the value is containing DL to CL, so that moves the data from DL to CL. This one, this way it is moving. Same way in the X, that is move X comma BX. X means it may be a any of lower or higher, so it is a AX. So A is missing here. Just you have to note down. This is the AX. Move AX comma BX. A is missing here or mistype here. So the value whatever containing the B register, that is transferred it into A register in the way of register addressing modes. So in next, that is direct addressing modes. So again direct addressing modes में वो क्या करना है, this mode of 16 effective address of the operand that's specified in an instruction. So here the instruction which is a effective address, that is EA, what we call it as EA, is nothing but effective address. So whenever you are going to be find the physical addresses, that time we are using this one. So effective address EA, that is the data in the memory. We are going to be manipulated with the instruction effective address. So here in that, for example, so there is a one effective address, that is a 4321H. So this is one hexadecimal. So we have to make it as a bracket. This bracket indicates what? That is present in the memory. This square bracket indicates that is a present in the memory. That value is going to be transferred to C register. So like this. So what is this present? That is a data segment. Wherever it is present in the memory means that is a data segment. So from that data segment to you have to transfer the value to the C register using the move instruction. So move CL comma square bracket 4321H, in the sense that 4321 hexadecimal value of data segment, we are transferred it into CL register, C register. Same way in the X, that is a 5678 hexadecimal value of the data segment memory, we transferred it into C register. That is the meaning. So it is about direct addressing modes. So next one, indirect addressing modes. In the indirect addressing modes, again 4 subtypes are there. That fourth one is the indirect addressing modes. So here in the indirect addressing modes, okay. So almost time is over. So please just 5 more minutes I have to continue. As you were, please cooperate me. Okay, that's fine. So in the indirect addressing modes, again there are 4 types. Nothing but register indirect addressing modes, and register relative addressing modes, register indexed addressing modes, and base indexed relative addressing modes. Okay. So here in the register indirect addressing modes, that is you have to use the instruction with the register, that is effective address to the data. So bx source index and destination index with the register. So for example here, to transfer bx whatever containing the value of b value to the cl, that is bx to the memory to the cl register, or you have to use with the base pointer with the cl register, that is cl to base pointer and base pointer to the stack segment registers. That is our indirect register addressing modes. So next one, that is relative addressing modes also. Here that effective address of an operand data is the sum of displacement and the contents of base register or index registers. So here it is also same with the source index and destination index. Along with the base pointer, you have to transfer B content to the instruction. So in this, there is a one address you have to use extra, that is register displacements and effective address with the data memory. So how? That is move CL BX plus 4. There is some extra also you have to use, that is the effective address. So here BX plus 4 with the memory to the CL register you are going to be transferred. So next one, based index addressing modes. So in this mode, the effective address of an operand data is provided in instruction, which is sum of base register, either it may be BX or BP, base registers or base pointers, and hence that index register is either source index or destination index, SI or DI. So here in the effective address, that BX plus SI source index and base pointer plus destination index. So that one you are going to be transferred with the previous one with the extra data memory of effective addresses. So that base address with the index address register, and that index is going to be you have to take with any one of the B register, that is BX. So add one more base pointer also you have to take with the base register, and finally you have to fetch the data of memory. So for example, move CL BX plus that source index is nothing but whatever the base pointer and source index is containing, that is transferred to the C register through the main memory DS, that is a data segment. Same way, either H or L we have going to be transferred. So in the Fourth one of register addressing modes, that is base index related to addressing modes. So in that again you have to use effective address with the BX and BP with the source index and the destination index for the 8-bit displacements, or it may be a 16-bit displacements as extended. So here one index and one base separately have to use it along with base register, index register, and displacement, and you get transferred and make it as a summation of effective address along with that memory data you are going to be used it here. So for example, that is a move bx this is a cl, you make it as it is cl bx plus di plus 20h, one extra memory you have to add it, that is all these you have to transport it into a c register along with main memory ds. So these all 4 points of our indirect addressing modes. Next one, we will move to implicit addressing modes, fifth one. It's the fifth category, implicit addressing modes. So in this addressing mode, the operations are implied and are hence not specified in the instructions. For example, that is a set to the carry flag stc, and we have to use clear the direction flag cld. Cld means in the sense what? That is a clear the direction flag, and stc means what? That is set the carry flag. So in this, so I have to give one example for whatever I explained now. Just all of you go through this example. In the next lecture, I will explain this examples. After that, I will move to branch related addressing modes. Okay. So tomorrow again, I got a class at 2:15. No, at 12:15. So at 12:15, I will start with this topic. That is branch related addressing modes and this examples of today's whatever I have to cover all addressing modes. Okay. So now what you will do, dear all students, just you have to wait. I will take attendance. Just I will take attendance. All of you wait for that. So again, you recall these notes and any doubts, please. Uh, you ask me. Okay. And 2010.
हॅलो सर एक जण लेफ्ट झाला.
Yeah, please. Hello. Just a second, I'll take attendance. Just a minute. Just a minute, don't go off. Yeah, yes, please. Dear all students, these examples, just whatever examples are there here in the addressing boards, you just go through these examples. Tomorrow in the next class, I will explain these examples and I'll start with all branch related addressing modes. Okay. So if we cover this branch related addressing modes, then the addressing modes of machine level instruction is over. Later on, we will start with some segmentations, part of things. Okay, fine. Dear all students, is there any question, please? Now, take a 5 minute and ask the questions. If no questions, then you may log out. So again, frequently try to ask the questions in my chat box. Please don't forget, and tomorrow in the class we will discuss in the open forum session.